I'm Akila Wickramasekara. So my research is AutoDFBench, a framework for AI-generated digital forensic code and tool testing and evaluation. So co-authors are Alanna, Hudan, Frank, and Mark Scanlon. So before I go into my research, I would like to introduce about my PhD and what I'm going in there. So motivation for my PhD is like growing digital evidence required efficient and automated solutions. And also another thing is that provide more accessibility to non-technical forensic investigators. And another thing is that reduce the manual effort, which improves the efficiency in forensic investigations. So with that, my objectives are that exploring the potential of using LLMs in digital forensic investigations. And another thing is that establish methodologies for designing and enhancing performance in LLMs. And another thing is that evaluate the effectiveness and advantages of using AI assisted frameworks. So with that, I would like to introduce why we need LLMs in digital forensics. So as you know that we have five phases like collection, preservation, examination, analysis, and reporting phases in digital forensics scenarios. And I have introduced this potentiality matrix to use LLMs for these kind of phases like low potential, medium potential, and high potential. So for an example, if you think about collection phase, it's kind of low potential of use LLMs because there are kind of much more need of human involvement for collecting evidences. But still, we have some kind of potential to use LLMs like evidence categorization and also identifying and listing evidences and things. And another thing is that in the preservation phase, that is kind of medium potential is there. So for an example, if you think about AI agents, we can use AI agents to automate disk imaging task and also disk hashing task with AI agents. So it's about the preservation phase, and for the examination and analysis and the reporting phase, it's kind of high potential thing that we can use LLMs. As example, if you think about examination phase, that its potential is like keyword searching and also file recovery and pattern matching is possible with the examination phase. And another thing is that in analysis phase, it is possible to get evidence interpretation and also timeline analysis kind of thing. And again, another thing will be like semantic analysis in the analysis phase. And reporting phase, that as you know that this is LLMs, it's kind of straightforward that you can generate report out of that easily way. So generating reports and combining the evidences with the report is kind of potential with the reporting phase. So with that, I have identified the challenges that can be best addressed by using LLMs like time, workload, and accessibility. So by focusing only on examination phase, so I would like to say that I have going on with digital forensic code generation by using LLMs, and also after that, then the execution of those codes and get the results out of that. But still, we have some kind of problems when we are thinking about this code generation and execution for the forensics, like how can we measure the accuracy of the generated digital forensic codes, and how valid is that output result, and how to validate the output results generated digital forensic code, and what kind of parameters to be used for the digital forensics code validations. So after that, I would like to introduce about this computer forensic tool testing program. So this CFTT is a program that developed by NIST, or National Institute of Standardized Technology. So it established a methodology for testing digital forensic tools to ensure reliability and accuracy. So these areas are like main task areas like disk imaging, string search, and file recovery, and also mobile forensics and cloud data extraction, and also memory forensics. So what NIST, the CFTT program does is they have kind of standardized test cases and testing in there, and they were used to verify the efficiency and accuracy of digital forensic tools. So with that, my key contribution towards this research are like designing an implementation of an open source benchmarking framework called AutoDFBench. So you can scan this QR and check the GitHub link. The framework is open source. And after that, testing the framework by using benchmarks for 5 state-of-the-art LLMs, like I have used 5 LLMs for that, by using 24,200 unique tests. And another thing is that getting some insights of LLMs, how they can generate, how much accurate they can generate digital forensic codes. But this is not the kind of a major thing, but it highlights that because the result is not good with the generated outputs, but it highlights that the need of proficiency, need of practitioners have to not to blindly trust LLM outputs. So framework design considerations are like configure, and this framework is like configurable and extensible. It means that it supports many kind of environments, because it's possible to change the parameters inside the framework, and it can be adjustable for any kind of environments. And also it's LLM and architecture agnostic. Like we can combine any kind of LLM, like local LLM or online LLM like ChatGPT or Cloud or something like that. And ground truth validation is there, and I'm using like use NIST CFTT analyze test and data accuracy checks for that. And also performance scoring, I have introduced that to get the precision, recall, and F1 scores to get the AutoDFBench scores. So there are 4 main phases in the framework, like API handling, code preparation, and code execution, and summary and evaluation. So in the API handling, it retrieves the job details and generate reports out via the LLMs. And in the code preparation, it will extract the code out of that generated text, and then in the code execution, it will execute those code as an executable file. And then in the summary and evaluation phase, it will generate the score, like AutoDFBench score, by checking with the ground truth data. So what is AutoDFBench score? So this AutoDFBench score is like getting the true positives, false positives, and false negatives by checking with the NIST CFTT ground truth data. And it will, for true positives, like matches between the results and ground truth data for specific test cases. And false positives are hits that test results that do not align with the ground truth. And also false negatives are expected outcomes from the ground truth not identified in the test results. And then I calculate these precisions and recalls, and then get the F1 scores of calculated each subsets. And then after that, I calculate the average F1 scores for those testings. So this is called as the AutoDFBench score. So this is the proof of concept that I created. As you can see that I was using Llama 3, StarCoder 2, Wavecoder as local LLMs by using OLlama Dockers. So they were implemented in separate Dockers. And also I'm using GPT-4 and Cloud 3.5 Sonnet as external LLMs, and I was using LLM library for that. And I was using these test cases and also human prompt engineering, and those prompts were combined as a job and feed it into this AutoDFBench framework. And then after that, I generate the report out of that framework. So as a proof of concept, I have conducted 24,200 tests. As you can see in this image, I was using Windows and Linux disk images. And also for test cases, like for Windows, it's like 62 test cases, and for Linux, it's 59 test cases. And I have conducted 10 multiple runs for each test. And I have using base prompts like beginner prompt and advanced prompt. So it will act like the beginner investigator who is entering prompts, and advanced like experienced investigator. And I was using, like, I was asking Python code and a bash code also by using 5 LLMs. So altogether, it's like 24,200 testings. So this is a flow diagram of the experiment. As you can see that I was generated some natural language queries by assisting GPT, and because I need some similar kind of queries, and I did human evaluation on those queries, and then save it into a CSV file, and then input that into the API handling phase. And it will combine the input it will combine the basic prompt and then send it to the LLMs. So then LLMs will generate the response out of that. and then after it will create a code file, like then it will extract the code and then create a code file out of that. So then that code file will be executed in the code execution phase, where after it will save the errors and also the results in the database. So that results will be again checked in the summary generation phase. So those results will be checked against with the NIST ground truth data and generate the F1 scores for those things. So this is a kind of result that I got from there, and this is for forensic string search, and I have addressed this as importance of detailed prompt. As you can see that blue color is for advanced prompt, and red is for beginner prompt, and yellow is highlighted in total prompts. So total hits that I got, and as you can see that in the advanced prompt, you can see that is a kind of a higher hits that we got, and for beginner it's like not much, but in Claude 3.5 I got like total 7,264 hits for the prompts that I given, and Llama 3 is like very low, like 660 total hits. As a note, that perfect hit count should be like 73,840. So it's like very minimum. So this is about the hit count, and this is about the bench mark in the benchmarker. So this is a result that I got as the AutoDFBench score. So as you can see, these numbers are very little. So I'm not showing that. I'm not saying that it's good numbers, but this result was highlighted that I'm making this framework reliable. So because I'm using like 5 LLMs, and it was I got the result out of that. So this is about 24,200 results, which took me like 980 hours to get these results. And as you can see, this best performing run is that run I got after 10 runs. I calculated the best, sorry, best results that I got. So that was indicated as the best performing run. So after that, I would like to say about my next goals in my PhD. So approximately I have 2.5 years to go, and my plan is to extend the framework applicability to evaluate digital forensic tools and AI-assisted digital forensic scenarios by using API for evaluation, and also I'm planning to embed NIST TFTT test procedures, all the test procedures along with this framework. For the moment, I'm working with deleted file recovery test, and then fine-tune an LLM for digital forensic code generation and also digital forensic task background. So it's on my pipeline and plan to complete by end of the August. And another thing is that AI agent implementation for investigators. So this is kind of a planned work in my PhD, uh, and it's planned to complete by November. And then after that, conduct a human trial with digital forensic practitioners and stakeholders with the framework that I have implemented in there. Then retire young, hopefully. That's it, and thank you very much. And any questions?
Thank you very much.